Okay, here we go. A couple of remote lessons today. We're going to start out with section 2.3, graphs and functions. Okay, so what we'll talk about a concept between the definitions of relations and functions. Something very important that you'll need to know for your math class is domain and range, how to identify that when you look at a graph or a function. Looking at a relation, whether it's a function or not, function notation. And then we'll talk about functions that are increasing or decreasing or constant functions. So let's go ahead and dig in. A relation is just a set of ordered pairs. Okay, by ordered pairs, I mean XY coordinates. Okay, so for example, if I had a set that was like this 1, 2, 2, 3, 4, 6, I'm just making these numbers up. This is a relation. It tells you that if you input a 1, you're going to get a 2 as your output. So the X is your input variable. So we think of this as our input, which is our X, and then our Y is just our output variable. So this is a relation. If you give it a 1, a 2 comes out. Input a 2, a 3 is output. Input a 4, a 6 is output. That's just what a relation is, okay? Now, we need to determine whether a relation is a function or not. So a function is a special definition of a relation. So let's look at this relation F. So F is defined with these three ordered pairs, okay? Now, a relation is a function if for each x value, we only get one y value back, okay? So if you look at it, in this case, 1 gives you a 2, -2 gives you a 4, 3 gives you a 4. So for every x value, you're only getting one specific y values. What you're really looking for here is I'm saying, are any of my x values repeated? Okay, I have all unique x values, so this is going to be a function. Now, if this had 1, 3, if this were added to that relationship, that would tell me that when you input a 1, you get a 2 and a 3 back. So in this case, if you have 1, 3 added, this is what makes it not a function. So when you look for a function, you're looking to see, are the x values all unique? That guarantees that you're getting unique y values. If the x values are not unique, that means you're getting two different y values for the same x, which makes it not a function. So the case we just did, yes, this is a function. Now let's look at the next one here. Is this a function? Now, if you look at it, what I'm looking for, I'm seeing, in this case, I see repeated x values right there. So I'm getting three different y values for the x value of 1. This is not a function, okay? Now, another way they show it to you, they show it to you in a mapping form. So they show you something like this. 1 and 2. And with 1, you get three different outcomes, 1, 2, 3. And with 2, the only outcome you get is 3. So this is not a function, because a function is for every x, there's only one unique y value. Okay, so in this case, I can see by looking at the ordered pairs when I see those repeated x values, and by looking here when I see an x mapped to different y values, that makes this relation G not a function. Let's decide whether this relation H is a function. So what I'm keying off of is, are there repeated x values? Yes. And I'm getting the different y values back. So that tells me that this is not a function. So it is a relation, but it's not a function because I see repeated x values giving me different y values back. Now we've seen those as ordered pairs. Another way to look at relations and functions is what we did sort of a moment ago, is in terms of a mapping or a diagram. So if you look at it in the example below, it tells me that this is really saying, this is the equivalent of writing F equal, and then the set of ordered pairs, 1, 2, -2, 4, and 3, 4, okay? So it's the same as writing it that way. So what I'm looking for are are there repeated x values? So if you look here, every x value only goes to one unique y value, one unique y value, one unique y value. Okay, it happens that -2 and 3 both go to the same y value, but that's okay. It's not repeated x values. Okay, so in this case, I can look and see none of my x's are repeated. This is a function. Look at the next mapping here. You see -4 is mapped to 1. And then now you see -2 is mapped to 1 and it's mapped to 0. So this is not a function because I have an x value that is mapped to two different y values, because I would have -4, 1, -2, 1, -2, 0. Those are all the three possible outcomes that you see from that diagram. And here you see repeated x values. So this is not a function. Now, when we talk about relations, we've talked about these ordered pairs, x, y coordinates, okay? So we typically think of them as x, y values. We can think of, and I've been using the words input and output. So you plug in an x and you get a y, input or output. Another way of thinking of this is you have two variables. You have your independent variable. That means you can pick a value for x, and then based on what you pick, you will get a specific y value for y. This is your dependent variable. Now, in a relation consisting of ordered pairs of x, y's, the independent variable we typically use as x. That represents the domain. The set of all values that x can be, that's the domain. The set of all values that the y can be is called the range of the relation or the function. So give the domain and the range of each relation and tell whether or not it's a function. Okay, the domain is the set of all x values. So what are all my x coordinates here? So the domain is a set of numbers. So it's just a list of numbers, 3, 4, and 6, okay? The range would be the set of all y values. What are the y values that I get here? So I see here are all my y values. So those are -1, 2, 5, and 8. So that is the domain and the range of this relation. Is it a function? Well, you should be pretty good at telling me now that based on that information, this is not a function. I've got the same x value mapped to two different y values. So it is a relation. I have a domain and a range, but this is not a function. Give the domain and range of this relation, tell whether or not it's a function. The domain would be the set of all the x values. So the domain, if I look at that mapping, is 4, 6, 7, and -3, just that set of numbers. The range would be the set of all output or y values, 100, 200, and 300. Is it a function? Well, I look and see, are there repeated x values? Is there an x mapped to two different y values? So in this case, I've got 4, 100, 6, 200, 7, 200, -3, 200. This is a function because I don't see, there's no case of any of the x values mapped to two different y values. Okay, so this is a function. So in this case, you see the domain and range, and yes, that it is a function. We can also look at it sort of in tabular form like this. Look at the relation that you see here and give the domain. The domain is these three numbers, -5, 0, and 5. The range, in this case, is just 2. That's all the range is. Now, is it a function? Do you see any repeated x values? No. Every x is only mapped to one y value, okay? So if I had something like this would make it not a function because you would see 5 mapped to two different values. So in this case, as it stands, the way you see it, This is a function, and you see the domain and the range. Now, how do we find the domain and the range if we're given a graph? So in this case, what we have is a relation that is 4 different points, okay? So what are the points that I have? I have 1, 2, negative 1, 1, 0, negative 1, and 4, negative 3, okay? Are there any repeated x values here? No. So this will be a function. What is the domain? The domain is the set of all x values. 1, negative 1, 0, and 4. 1, 1, negative 1, 0, and 4. The range is the set of all the y values. Looks like 2, 1, negative 1, negative 3. 2, 1, negative 1, negative 3. So here's the range, and here's the domain. Now, how do we find the domain and the range when it's not just a set of points, but it is a graph? So this is an oval or an ellipse. So to find the domain, and this one is not just, random points, but I see the domain. To find the domain, you're going to travel on the x-axis. So let's start over here. We are at negative infinity. There are no x values. I do not see an x value until I get right there, okay? What is that point? That is 1, 2, 3, 4, 5. So, wait. Sorry, I counted wrong. 1, 2, 3, 4, negative 4. So I do not see any x values until I get to negative 4, okay? Now, I'm looking at the blue line, is where my function is. So it looks like as I travel along the x-axis, so I started here, this is where I first see an x value. It looks like there are x values in that graph all the way here to here, and then they stop because there are no more x values over here. So this only has x values for every number between negative 4 and 4. So the domain is an interval in this case. It's the interval from negative 4 to 4. I use square brackets because it includes that. So again, the way you find the domain and range in a graph, domain means x. There are no x values over here at negative infinity. I do not see my first x value until I get right there at negative 4. I keep on getting x values, and I keep traveling in x, and then this is the last x value I will see. There are no more x values. So x values only exist from negative 4 to 4. So let's do the same thing for the range. Range is the only time you look at the y-axis for your values. So down here, there are no y values. I do not see my first y value until I get to negative 6. I continue to see y values all the way up here until I get to positive 6. And after that, there are no more y values. So the range is negative 6 to 6. Okay? So that's how you can look at a graph and tell its domain and range. Domain is the horizontal for the x, and range is the vertical. Now look at this one. What you've got to keep in mind, and when you see a graph like this with the arrows on the end, that means this keeps on going forever, okay? So if you start over here for the range, see the domain, start at negative infinity. Yeah, there are x values. This graph is going to keep on going forever, okay? So no matter where I start, there are x values. And as far as I keep going, this graph down here is going to keep on going to the right. So it looks like for this case, the domain of this function is going to be negative infinity to infinity. And I always use parentheses with negative infinity. And then let's look at the range. Are there y values here? Yeah, this graph, remember, it's going to keep on going down and to the right. So I will have y values all along this axis. So the range, same as the domain, is negative infinity to infinity, okay? So the domain and the range are the set of all real numbers in this case. Okay, let's look at the next one here and determine its domain and range. So this one is a parabola. We'll talk a little bit about this more later, but key point, this has arrows on the end of it. It keeps on going forever and ever, okay? So it's going to keep going. This is going up to the left. This is going up to the right. So my domain, start over here at negative infinity. Well, if this graph keeps going up and to the left, I will have value. There are x values here all along this axis. So I see x values everywhere. So my domain is going to be from negative infinity to infinity. Range, that is the only time I go to the y-axis for an interval. This graph has no y values down here. So it looks like I do not see any y values until I get right there. That point is -3. That's my first y value. And it's going to keep on going up forever. So it looks like my range is going to be from -3, including -3, all the way to infinity. So again, we're using interval notation here with domain and ranges. And we'll skip that point there. There's something called a vertical line test. When you look at a graph, you can tell if it's a function if it passes what's called the vertical line test. So rather than talk a lot about that, let's just go into an example. So let's look at this. Look at the function right here. If I can draw a vertical line and it only crosses my relation in one point, it is a function. So what I did here, I've got these 4 points. So these were the 4 points in my original relation. And if I can draw vertical lines, which is what you see here, through every one of those, every time I draw a vertical line, I'm only touching the relation one time. It's not going through multiple points. This is a function. Okay. Now let's look at another example here. Is this a function? If you draw a vertical line here, so in this case, I draw a vertical line right here, and it tells me that I have crossed this graph 2 different times. So that tells me that whatever this x value is, which is -2, there's a possibility of getting a 6 and a -6. So it tells you that on this graph, you've got both of these points. Well, that means you've got a repeated x value giving you different y values. This is not a function. So anytime you can draw a vertical line, no matter where it is, and it crosses your graph more than once, that's not a function. So let's look at this. Is this a function? No matter where you draw a vertical line here, it only crosses that blue line one time. So yes, this is a function. Let's look at the next one. Is this a function? No matter where I draw a vertical line, it's only crossing that graph one time. So yes, this is a function. Trying to think in this one. I'm going to skip this part. If I ask you if it's a function, I'm going to give you the points or I'm going to give you a graph. Here I'm giving you a definition, but I haven't graphed it yet. So I'm going to skip this one. I'm going to skip this as well for now. And we'll move on a little bit. And I'm going to skip this as well. So when we talk about functions, remember a function is a relation in which the distinct value of the first component of the order pairs is only exactly one value of the second component. Okay, so what we've talked about no repeated x values. So when you look at your xy coordinates, there are no x values that are repeated. Another way of saying it, for every x, there's only one y value that gets assigned. Okay, so only one range. Another way of saying it, only one range value for each domain value. These are all equivalent ways of talking about a function. Now we need to talk about function notation. Okay, whenever we have a function, that means you've got a rule that when you have an x, you get a certain corresponding value of y. We say that y is a function of x. And this is the way we're going to say this. Y is a function of x. What this means is we'll say y equals f of x. Okay, this is not multiplying that f times an x. These are not two variables multiplying. It's saying that y is defined as a rule. You give me an x, and then I will give you y as an output. Okay, so really all we're doing here is you think of when you have a function like this is a line, y equal a linear equation 3x minus 5. To write it in function notation, we're just going to substitute f of x for y. So we're going to say f of x is equal to 3x minus 5. That means if you give me an x, what f is going to do is going to give you back 3x minus 5. So f of 1 means substitute a 1 in for x. So f of 1 is going to be 3 times 1 minus 5. That's 3 minus 5, which is negative 2. F of 0 is 3 times 0 minus 5, which is negative 5. F of z is 3z minus 5. Okay, all you do is it's a substitution notation or function notation, and we'll be using this probably pretty much through the rest of the class. So f of x is just another way of talking about that independent variable, that output variable, that range variable. Okay, so in this case we did a couple examples. F of 2, you just substitute a 2 in for x, and you get that. So in this case, if we look at, remember x is our input or our independent variable, y was our output or a dependent variable. All we're doing is saying, let's write this in a different format, f of x. So it's written into a function notation or a substitution notation because it tells me what value do you substitute in for x and what rule do you use to bring that value back. Okay. So keep in mind, this does not mean when you write f of x, it doesn't mean f multiplied by x. It means substitute an x into the rule for f. So I'm going to give you in function notation two different functions, f and g. Find and simplify the following. F of 2, okay? Here's my rule for f, okay? So f of x is equal to minus x squared plus 5x minus 3. F of 2 is just everywhere you see an x, you're going to replace it with a 2. So what you see here, this, keep in mind, these are two different things, okay? Negative 2 squared, this first one, this is a negative number, and this is a negative number being squared. So this is negative 4 plus 10 minus 3. So this turns out to be 3. So it tells me that the point 2, 3 is on my graph, okay? Because when you substitute a 2 in for x, you will get a 3 for your y value. Find f of q, okay? One moment. We're looking at f of q. So all you're doing is taking f of x is equal to minus x squared plus 5x minus 3. F of q. It's just everywhere you see an x, change it to a q. And that is f of q. Now find the next one, they're saying find g of a plus 1. Okay, so g of x is equal to 2x plus 3. Now what I'm being asked to find is g of a plus 1. So that's going to be equal to 2. Instead of an x, I'm going to write a plus 1 here, plus 3. So all I did was replace the x with an a plus 1. And what is this? This is 2a plus 2 plus 3. This is 2a plus 5. Next example, so we did that g of a plus 1. And this next one, for each function, find f of 3. So in this case, all you do is plug in a 3 for x. So when you plug in a 3 for x, that's 9 minus 7, which is 2. Find f of 3 in the next function. That means when you have an input value of 3, what is your output value? That is 1. So this tells me that f of 3 equal 1. When x is 3, y is 1. Find f of 3 here. That says when you input a 3, what is your output? That's 5. This tells me that f of 3, I'm having trouble here with the, so in this case, f of 3 equal 5. I'm having trouble with my board writing here. I'll have to start that in just a moment. So f of 3 equal 1 in this particular case. Let's continue on. Look at the graph that you see here. So in this case, I'm being asked to find f of 3. So you look at your x-axis that you see right here. And let me just talk through it since I'm having trouble with my board. You look at your x-axis. So that is the horizontal axis that you see here. Your vertical axis is your y-axis. So f of 3, when you look at your x value of 3, what is your y value on this graph? You get a 4. So you input a 3 for your x value, and what comes back, so when you have an x value, what comes back is your y value of 4. So here f of 3 is equal to 4. The last thing is just writing something in function notation. So if y is equal to x squared plus 1, to write that in function notation, it's just going to be f of x, and I'm going to have to give up here on the second writing. So all you do is f of x is equal to x squared plus 1. So all you're doing here is, in this case, f of x is x squared plus 1. Replace the y with f of x for function notation. And the next one, to write this in function notation, first thing you have to do, you have to solve for y. So x minus 4y equal negative 5. Negative 4y equal negative x plus 5. Divide everything by 4. Now I've got it solved for y. To put it in function notation, just replace the y with f of x. So f of x is x minus 5 over 4, or 1/4 x minus 5/4. And then we just need to talk about functions being increasing or decreasing. When we look at this, the way to tell if a function is increasing or decreasing, you travel from left to right. So I'm over here. If I travel from left to right, then if I look at this function right here, what would happen? So if I go from this point to this point, the function is going down. So it tells me that this function starts out decreasing. It decreases until it gets to 1, okay? And then at that point, it starts increasing. It increases from 1 to 3, and then it's constant from 3 on out. So if I look at this function that you see graphed, and they've got a repeat for that. So it tells me that from negative negative infinity to 1, this graph is decreasing, okay? And note the open parentheses on the 1, because you see that open circle. So this function decreases from negative infinity to 1. What happens at 1? Well, it jumps up here to the value of, what is this, 4. It increases between 1 and 3. So you see here it increases from 1 to 3. We got closed brackets, and then it is constant. It neither goes up or down. So it is constant on the interval from 3 to infinity. And there we go. And they got an example here of looking at a graph and giving back some information. So let's look at the one, it's a word problem here. It talks about a pool. This shows the relationship This graph shows the relationship between number of gallons of water in a small swimming pool. You look at this graph, you see, okay, the hours are at the column on, the rows on the bottom, and the gallons you see in the vertical. So it tells me that at 0, my pool is empty. So what's happening here in this case? And in this case, what's happening is you're filling the pool up. So it looks like it takes you, in this case, for the first 25 hours to get to 3,000 gallons, okay? Then your pool stays at 3,000 gallons until about 50 hours. And then it looks like your pool goes down to 2,000 hours and then it stays constant. So what does this represent? It looks like you had an empty pool, you filled it up to 3,000. It stayed there for, maybe roughly a day. And then it looks like you drained the level down to 2,000 and then it stayed there. So here's a function, and you can see this function increasing. It's increasing when I first start, it is constant, and then it decreases, and then it's constant. So that's just a way of looking at something graphically and telling if it's increasing or decreasing. And that should be it. They ask a question, how long is the pool increasing? Well, it's increasing for the first 25 hours, okay? And it's decreasing. My graph just keeps jumping around, so sorry guys, I probably need to reboot this machine. So they're asking about what it's doing. It looks like it is increasing for the first 25 hours, and then from 25 to 50, it's constant, and also from 7 to 10, it's constant, and then it's decreasing from 50 to 75. Okay, sorry about the technical glitch here on this, but this should be the end of section 2.3.